This is the first of several videos talking about different market structures or competitive environments in which firms compete. In this video, we are talking about perfect competition in the short run. Perfect competition is the most competitive of the market structures. If you are a manager, how could you tell whether or not you are managing a firm selling a product in a perfectly competitive market? In a perfectly competitive market, you can sell as much as you want at the going market price. If you have market power, on the other hand, to sell more, you must lower your price. So if the firm in perfect competition is charging the going market price, it never has to lower its price to sell more. But if it raises its price just 1 penny above the going market price, it will sell nothing at all. A firm with market power, on the other hand, can generally raise its price without losing all of its customers. The reason why this is because firms in perfect competition sell products for which there are many other firms selling a perfect substitute. If Farmer Jake raises USDA certified organic hard red wheat, he is selling exactly the same thing as Farmer Ann and Farmer Betty and every other farmer raising USDA certified organic hard red wheat. There may be millions of farmers raising a perfect substitute. Recall that more substitutes means more elastic. Many perfect substitutes means perfectly elastic. This means consumers are infinitely responsive to a price change. Since any one farmer is too small to affect the world price of wheat, she can sell as much as she wants at the going market price. However, if she raises her price just 1 penny above the going market price, she will lose all of her customers because there are other farmers selling an identical product for less. The graph on the left represents a perfectly competitive market. In the market, there are many buyers and many producers buying and selling from each other, which generates a market price. The graph on the right represents the demand curve for one individual farmer's product. It is horizontal because the demand is perfectly elastic. Again, since the farmer is raising a product that is identical to many other producers, if she raises her price just 1 penny above the going market price, the demand curve shows that she will not be able to sell anything at all. But at the going market price, she can sell as much as she wants. Suppose that the market price for a bushel of wheat is $5. If this is the case, here is the demand schedule for the first 6 bushels of wheat for a single farmer's wheat. Total revenue is equal to price times quantity. So here is the total revenue filled in for the entire table. Marginal revenue is equal to the change in total revenue over the change in quantity. Please fill out the marginal revenue for each of the quantities. What is the marginal revenue for the 6th bushel of wheat? The marginal revenue for the 6th bushel of wheat is $5. In fact, the marginal revenue for each bushel of wheat is $5. This is because the market price is $5. Each time the farmer sells another bushel of wheat, she gets $5 additional because she sells it for the going market price of $5. So the firm's demand curve is horizontal at the market price. Also, the firm's marginal revenue curve is horizontal at the market price. Demand and marginal revenue both equal the market price. If we graph total revenue, we get the top graph. When the market price is 5, every time quantity increases by 1, total revenue increases by 5. So the slope of the total revenue curve is price. In fact, by definition, the slope of the total revenue curve is marginal revenue. Marginal revenue is equal to the change in total revenue from a change in Q, which is the rise over the run for the total revenue curve. The slope of total revenue is constant, which implies that marginal revenue does not change with quantity, but is horizontal at the market price. Here we have added the total cost curve and the marginal cost curve. These curves are described in the short run cost video. As discussed in the previous video, the slope of the total cost curve is marginal cost. The firm's goal is to maximize profit. Profit is the difference between total revenue and total cost. Profit is maximized when the vertical distance between total revenue and total cost is at its greatest in the top graph. At this point, the slope of the total revenue curve is equal to the slope of the total cost curve. That is, when profit is maximized, marginal revenue is equal to marginal cost. So in the bottom graph, we see that at the profit maximizing quantity, Q star, the marginal revenue curve and the marginal cost curve cross. When farmers maximize their profit, they make their decisions at the margin. Recall that in economics, marginal means additional. When we say a farmer makes her production decisions at the margin, we mean she weighs the additional benefit and the additional cost of producing a little bit more or a little bit less. You can see in the graph that when the marginal revenue is greater than the marginal cost, profit increases as the farmer produces more. This is because the additional revenue is greater than the additional cost of producing another unit. These additional production decisions more than pay for themselves. After the point where marginal revenue equals marginal cost, if the farmer produces more, the additional cost is greater than the additional revenue. So producing more starts decreasing profit. You can see after the point of Q star in the top graph that cost is increasing faster than revenue. That is, marginal cost is greater than marginal revenue. If we add the average total cost curve and the average variable cost curve, we can calculate firm profit and producer surplus. Suppose that market price is $10.50. What is the profit maximizing quantity? To find the profit maximizing quantity, we keep producing as long as marginal revenue is greater than marginal cost, and then stop where marginal revenue is equal to marginal cost. In the graph, this is where $10.50 equals marginal cost. So the profit maximizing output is 1,000. Now, what is the maximum profit? Go ahead and take a minute to solve this problem. This applies what you learned in the short run cost video. Once again, the profit maximizing output is where marginal revenue equals marginal cost. To solve for profit, we need total revenue and total cost. Total revenue is simply price times quantity. $10.50 times 1,000 gives us $10,500. Recall that you can get total cost by rearranging the average total cost formula. Total cost is average total cost times quantity. For the profit maximizing output of 1,000, total cost is $8,500. So profit is total revenue minus total cost, or $2,000. There's a way that we can rearrange the profit equation to get an easier, more straightforward way of calculating the profit. Recall that total revenue is price times quantity, and total cost is average total cost times quantity. If we substitute in for total revenue and total cost, we get this equation. Now we can factor out quantity, so profit is equal to price minus average total cost times quantity. Price is revenue per unit of output, and average total cost is cost per unit of output. So price minus average total cost is profit per unit of output. So if you take the profit per unit of output and multiply it times the output, you get profit. Plugging in for the specific values in this problem, we get $2,000. Rewriting profit this way enables us to find profit on the graph. The height of this rectangle is price minus average total cost, or profit per unit of output. The base is the output. Multiplying height times base gives us profit. Suppose that market price is $8. What is the profit maximizing quantity? What is the maximum profit? Go ahead and take a minute to calculate the profit. Once again, the profit maximum output is where marginal revenue equals marginal cost. Let's go ahead and use our profit formula containing price and average total cost, because that is what is explicitly given to us in the graph. Here, both price and average total cost is $8. So the difference between price and average total cost is 0. Profit is 0. Recall that economic cost includes both explicit cost and implicit cost. So when economic profit is 0, this implies that the firm is doing just as well as its next best alternative. That is, the firm is earning a normal rate of return. Suppose that the market price is $7. What is the profit maximizing quantity? What is the maximum profit? Go ahead and solve this problem. Once again, the profit maximizing output is where marginal revenue equals marginal cost. Plugging in for price and average total cost into the profit equation, we get a profit of negative $937.50, or in other words, a loss of $937.50. The profit rectangle now gives the area of the loss. If the market price is $7 so that the firm is earning a negative economic profit, is this firm going to shut down and produce nothing in the short run? To help answer this question, it is helpful to know what fixed cost is. This is because if the firm shuts down and produces nothing at all, the firm still has to pay its fixed costs despite the fact it no longer has any revenue. So when the firm shuts down and produces nothing at all in the short run, its profits are equal to the negative of fixed cost. Go ahead and calculate the firm's fixed cost and then use this value to answer the question. What is the firm's fixed cost? What is the firm's profit if it shuts down and produces nothing at all in the short run? Average fixed cost is the vertical distance between the average total cost curve and the average variable cost curve. At a quantity of 750, we find that the average fixed cost is $2. If we multiply this by quantity, we get a fixed cost of $1,500. Fixed cost does not vary with output, so this is the fixed cost at any level of output in the short run, including when the firm shuts down and produces nothing at all. So if the firm shuts down and produces nothing at all, its profit will be negative $1,500. If the market price is $7, should the firm shut down and produce nothing in the short run? Here the firm has a choice to lose $1,500 by shutting down or to lose $937.50 by staying open and producing $750. By staying open and producing, it minimizes its losses. This is because $7 is greater than average variable cost. $7 covers all of the variable costs and some of the fixed costs. Thus, the revenue the firm brings in helps cover some of the fixed costs. Again, if the firm shut down and produced nothing at all, the firm would not have any revenue to help cover the fixed cost. How much better off is the firm if it stays open and produces rather than shuts down? If the firm stays open and produces 750 units of output, its profits are $562.50, more than if it shuts down and produces nothing at all. This is the difference between the profit at 750 bushels of wheat and the profit when shutting down. This dollar amount is called the producer surplus. It is the gains from trade for the firm from producing the 750 bushels of wheat. The short-run producer surplus can be found by adding fixed cost and profit. This gives how much better off the firm is if it stays open and produces rather than shuts down. This equation is actually equivalent to what we did before. Since when the firm shuts down, its profits are negative fixed cost, it has positive producer surplus even when profits are negative, if these profits are greater than the negative fixed cost. When will the firm actually shut down? The firm will shut down and produce nothing at all if the price drops below average variable cost. When price drops below average variable cost, it is no longer even covering its variable costs. The variable costs are things like the cost of workers that the firm can eliminate by shutting down. Suppose that the market price is $5.20. What profit will the firm earn if it produces an output of 625? What profit will the firm earn if it shuts down and produces nothing at all? What should this firm do to maximize profit? To answer this question, let's compare the profit when the firm produces at the point where price equals marginal cost. At this point, quantity is 625 and average cost is $8.60. Plugging these values into the profit equation, we get a loss of $2,125. If we use the values given here to calculate fixed cost, once again we calculate a fixed cost of $1,500. This is as it should be. Fixed cost does not vary with output, so it will be $1,500 at any level of output. So if the firm shuts down and produces nothing at all, the firm's profit will be negative $1,500. A loss of $1,500 is preferable to a loss of $2,125. So the firm should shut down and produce an output of 0. Again, the reason the firm will shut down here is because price is less than average variable cost. At a price of $5.20, the revenue is less than the firm's variable costs. Let's review what we have learned here. The firm will choose the output where profit is maximized by producing where price is equal to marginal cost. Since marginal revenue always equals price in perfect competition, this rule is the same thing as marginal revenue equals marginal cost. When price is greater than average total cost, the firm will earn positive economic profit. When price equals average total cost, economic profit is 0. When price is between average total cost and average variable cost, profit will be negative, but it will be best for the firm to still produce where price equals marginal cost. By so doing, the firm will minimize its losses. When price drops below average variable cost, the firm will minimize its losses by shutting down and producing 0 output in the short run. It will still have to pay fixed costs, so profit will be negative fixed cost. Since the firm produces where price equals marginal cost, anytime price is greater than average variable cost, the marginal cost curve is the firm's supply curve in the short run. Below average variable cost, quantity will be 0. The firm's short-run supply curve is shown here in red. Suppose there are 100 identical firms in the market. Which of the two graphs on the right represent the short-run market supply curve? The correct answer is the top graph. When the price is $10.50, there will be 100 firms, each supplying an output of 1,000. This implies that the market quantity supplied will be 100 times 1,000, or 100,000. The same logic applies for each of the prices. The problem with the lower graph is that the supply does not drop off to 0 once price drops below $6. Recall that when price drops below average variable cost, each firm will shut down in the short run. I think we are ready to return to our consulting project with Jake. Suppose that his pizza is identical to the pizza produced by many other firms and that the market is highly competitive. This is probably not a good assumption to make. Hopefully, Jake will differentiate his product so he will not be a price taker. However, here we are assuming he is not differentiating his product, so he is best off charging the going market price. If the market price is $9, how many pizzas should Jake produce? What will be his profit? To maximize profit, Jake will want to keep producing as long as price is greater than marginal cost. If you look at the table when quantity is $16, the marginal cost is 4. So if Jake produces the 16th pizza and sells it for $9, the additional revenue will be $9 and the additional cost will be $4. Since marginal revenue is greater than marginal cost, producing the 16th pizza will increase his profit. For the 20th pizza, this is still true. Marginal cost is $5 and marginal revenue, which is also price, is $9. Since marginal revenue is greater than marginal cost, producing the 20th pizza will increase Jake's profit. For the 23rd pizza, marginal revenue is still greater than marginal cost. For the 25th pizza, though, marginal cost is now $10, which is greater than the marginal revenue of $9. If Jake produces past 23 pizzas, his profit will start declining. To maximize profit, he should produce 23 pizzas. If the market price is $6, how many pizzas should Jake produce? What will be his profit? Once again, Jake will keep producing as long as his marginal revenue or price is greater than his marginal cost. This puts him producing 20 pizzas. Plugging in for price and average total cost in the profit equation, we solve for a profit of negative $60. Should Jake shut down? No, the price is still greater than average variable cost. If he shuts down in the short run, he will have a loss equal to fixed cost, which is $100. Better to lose $60 than $100. So he will minimize his losses by producing 20 pizzas. Make sure you can use this table to calculate fixed cost. A trick is to remember that fixed cost is the same for any quantity. So you can pick a row where the average cost data are nice round numbers that are easy to work with. You can see that when 20 pizzas are produced, the average fixed cost is $5. Multiplying output times average fixed cost gives us a fixed cost of $100. It is also easy to calculate fixed cost when output is 5. You will still get a fixed cost of $100. Again, if Jake shuts down and produces 0 pizzas in the short run, his profit will be negative fixed cost, or negative $100. He will do this if price drops below minimum of average variable cost.